This lesson will focus on graphing conics. By the end of this lesson, you should be able to graph each conic, including the conics that have been translated around the graph. You should notice that this is a parabola because one variable is squared and the other is not. And because the y is the squared variable, this one's going to open left or right. You can also remember it because just like with the hyperbola, the letter that's squared is where it's going to open up to, or where the vertex is going to be. So because nothing is added or subtracted to the x and the y, our vertex is at 0, 0. And now we need the focus and the directrix. And remember that it's already set up, so y squared equals 4px. So this 1/4 equals 4p. And then to get the p by itself, we would divide both sides by 4, which is the same thing as multiplying by 1/4. So the p, or the focus, is at 1/16. And that's positive, so 1/16 is pretty close to the 0. And so our graph is going to open up this way, and our directrix is going to be at negative 1/16. Or something right about there. So we have the focus at 1/16 and 0. We have the directrix at x equals negative 1/16. And we have the center at 0, 0. And our parabola can be fairly inaccurate. I'm focusing more on where that focus is, where that directrix is, and which way it opens up. You should be able to recognize that this one is a circle. We have x squared, y squared, and it's equal to something squared. So we know that our radius is 5 because we take the square root of that 25 to get the radius. So we go out to the positive 5. And this one is centered around 0, 0 because nothing is added or subtracted to the x and the y. 5. So our graph looks like a circle like this. And we label the parts. This is the center. We could label the radius. That's 5. And that's all we need for a circle. Okay, we see this equation and we should be able to tell right away that it's a ellipse. And in order to graph the ellipse, we've got to divide by 64 because it needs to be equal to 1. Oops. 64. And then we simplify each one of those fractions. 4 goes into 64 16 times. 16 goes into 64 4 times. And then we get equals to 1. And then the numbers underneath tell us where the points on our ellipse is going to go. So we take the square root of those numbers, and we get 4 and 2. And because the 4 is underneath the x, then we put the 4 on the x-axis. And because the 2 is underneath the y, that goes on the y-axis. Then we connect the dots to make it look like an oval. We know that it's centered on the 0, 0 because there's nothing added or subtracted to the x. We can label the vertices. The vertices are always on the longer side. And that's at negative 4, 0 and 4, 0. We can label the co-vertices because those are always on the shorter side. That's at 0, 2. And 0, negative 2. And then we need the minor axis. So this one is the minor axis. It's the shorter axis, remember. And the major axis. Remember, that's the longer axis. And the last thing we need for the ellipse is the foci. So we use the equation c squared equals a squared minus b squared. Remember, that equation is always the opposite of the sign inside the conic. We plug in our numbers, so we get c squared equals 16 minus 4, which is 12. Then we have to take the square root of that 12. And 12 is between 9 and 16, so it's between 3 and 4. So somewhere right about there. Remember, it's just an estimate. It doesn't have to be perfect. So that's a focus over here and a focus over here. Right away we should be able to tell that this is a hyperbola because of the subtraction symbol. So we need to divide everything by 225 so we can draw our box and our asymptotes. 25 goes into 225 9 times. 9 goes into 225 25 times, and then that's equal to 1. And again, just like with the ellipse, we take the square root of the denominators and we get 3 and 5, and that tells us where to go. The 3 is underneath the y, so that's where we go on the y-axis. The 5 is underneath the x, so that's where we go on the x-axis. Then we draw our box. And remember, the box is imaginary. It's not really there, but it's there to help us draw our hyperbola. And then our asymptotes connect those two corners together. Again, dashed because they're not actually there. And then with the y squared being forward, that's where our hyperbola is going to go, our two parabolas, one at this y and one at this y. So we have our asymptotes. These are our asymptotes. We have our vertex, or our vertices, one vertice there and one vertice here. And we have our square or our rectangle, and the last thing we need is our foci, and that's got the opposite sign of what's in the equation, so it's plus instead of minus. We get c squared equals 25 plus 9, which is 34. And then we need the square root of that, and that is between 25 and 36. So it's between 5 and 6. 1, 2, 3, 4. Somewhere up here. That's where our focus is, up there. And then our other focus is right about there. And we've labeled everything we need on our hyperbola. Now we have a circle that is not centered at 0, 0 because we have something added or subtracted to the x and the y. So our center this time is at 2 and negative 3. Remember, we take the opposite sign of what's inside the parentheses. So now our circle is at 2, negative 3. And our radius, we take the square root of that, is 3. So 1, 2, 3 from the center this way, to the left, and down at the bottom. So our circle looks like this. We can label this the center at 2, negative 3. And then we label the radius as 3. Now we have a a ellipse because it's plus. It's already set equal to 1. So we can find our center now being at 2, 1. So our center is at 2, 1. It's right here. And then we take the square root of the numbers underneath to draw our ellipse. So we take the square root of 16 and we get 4. The square root of 9 is 3. And because the 4 is underneath the x, we go 4 on the x to the right and to the left. And because the 3 is underneath the y, we go up 3 and down 3 and draw our ellipse. And the last thing we need is the focus. So c squared equals a squared minus b squared. So c squared equals 16 minus 9, which is 7. And when we take the square root of that, that's between 4 and 9. So between 4 and 9 from the center, which means that square root of that, that's between 2 and 3. So between 2 and 3 here, and 2 and 3 over here. So this is our focus. We have our vertice, or vertex, and then here's a vertex. Then we have a co-vertice, a co-vertex, and a co-vertex over here. We have this being our major axis because it's the longer axis. that one being our minor axis because it's the shorter axis. In our last example, you should be able to tell because of the subtraction symbol that this is a hyperbole and it's already equal to 1. So our center for the hyperbola is -3 and +4. No, that's wrong. Our center is at +4 and -3. Being careful because the 3 is with the y and the 4 is with the x. So we draw our center at 4, -3. Now we need to draw our box. So we take the square root of the denominators and get 1 and 2. The 1 is underneath the y, so we go up 1 and down 1 on the y. And the 2 is underneath the x, so we go over 2 on the x. And then we draw our box. And we draw our asymptotes. And because the y comes first, that's where the vertices are, this way and this way. So we have our center at 4, 3. We have our vertices at 2, -3, and 6, -3. Oh, sorry, 4, -3. 6, 1, 2, 3, 4, 5, 6, and 2, -3. We have our co-vertices at 4, -2, and 4, -4. And these are asymptotes. Last thing we need is the focus. Remember, we use c squared equals a squared minus b squared. No, sorry, plus b squared. So we take 4 plus 1, which is 5. Take the square root of that, that's between 4 and 9. So about 2, 1, 2, between 2 and 3, closer to 2 than a 3. Right about there, and that's where our foci is. In our last example, you should be able to tell is a parabola because there's only one variable squared. The vertex in this case is at 2 and -3. Oops, not the center. The vertex is at 2 and -3, so 2, -3. We know that it's going to either open up or open down because the x is the squared. And this number in front of the y should be equal to 4p, because remember, v minus h squared equals 4p and not vx, and y minus k. So we set that equal to 4p and divide by 4, so p is equal to 2. +2, so that's the focus, which means that at the -2 behind it, or 2 behind it, that should be the directrix. X equals 0, and this thing is going to open up towards the focus, just like that, with the vertex here at 2 and -3.